So we're continuing on with our stoichiometry calculations. In this video, we're going to be looking at limiting reactants and percent yield. Alright, so when we talk about percent yield, typically when we have a reaction, we don't get out of the reaction what we would think we would. So we have what's called an actual yield. So the actual yield is what you would get when you get done with the reaction and you actually measure how much that you got. Then we have a calculated yield, which we call the theoretical yield. So the theoretical, we're going to calculate with those stoichiometry calculations. The actual yield is something that you would do in the lab, and then you would be able to measure that. So the analogy that I would like to give is, let's say that I'm going to make cookies, and when the recipe says that I can get 2 dozen cookies. Well, let's say that when I get done, that I actually only made 20 cookies instead of 24. So I didn't quite make as many as I thought. And typically in a chemical reaction, this happens. I'm going to lose some. There's going to be inefficient processes that are going to result. I might lose some of the product. There's a number of reasons that you wouldn't get exactly what you had calculated or what you thought you were going to get. So we a lot of times calculate that percent yield. So we'll start with the reaction again. And you'll always want to make sure that the equation is balanced. In this case, we can see that it's balanced. And we're going to start with 131.85 grams of my reactant. And they want me to figure out the percent yield for this reaction, and they're telling me that I have made 124.28 grams. So this amount that you are given is the actual yield. Now, how you're going to know you have one of these percent yield problems is that they are going to give you the amount that you start with, but then they're also going to be given the amount of something that you produce. So that's not something that we've seen before. So in order for me to find my percent yield, I'm going to have to calculate that theoretical. And just like in our last video, this is going to take those 3 steps. So the first one is I'm going to have to figure out my molar mass. Mn is not one I had memorized. 54.938. And then we'll add those together. Alright, so since I have grams on the top, I'm going to put the grams on the bottom. Okay, then my next step is I'm going to do that mole to mole ratio, and I'm looking at my coefficients in my balanced equation. So I put what I want, so 1 mole of M3O4 for every 3 moles of MnO2. And then finally, I'm going to multiply by my molar mass of the M3O4. I left off my N, Mn. So Mn and O This is going to be 3. And this is 4. Alright, so 1 mole of Mn3O4, and then up here 228.8116 grams. And I'm going to just double check that molar mass again. Okay. So then multiply everything on the top and divide by everything on the bottom. Alright, I got 115.6733 grams. I'm going to double check that number again. Alright, 6, 7, 3. Okay, and I have 5 here, a lot there, exact numbers, and 7. So I'm going to need 115.67 grams of Mn3O4. Okay, and I have apparently made up a number that I probably shouldn't have. I'm going to have to edit this problem. My actual yield has to be less than my theoretical. So I made up these numbers. I'm going to change that to 104. Now that would be given in your problem. So it shouldn't be a mistake like this one. Okay, so to find your percent yield, you're going to take your actual divided by your theoretical times 100. And as I said, the actual has to be less. And I had made up those numbers, that's why mine didn't work. Okay, so 104.28 divided by that number. Top number has 5, the bottom number has 5, so I need 5. So 90.150%. Alright, so the actual problem here where we were calculating the theoretical yield, this is nothing different than what we were doing for our stoichiometry calculations. The only new thing in this problem was this last step where I did the actual divided by the theoretical. Otherwise, the rest of this is not anything new for us.